So let us start with the third part of the discussion on tropical cyclones, that is the distribution of tropical cyclones. Now if you see, most of the cyclones, be it hurricanes, cyclones in Indian Ocean region, typhoons in Pacific part, in the South China Sea region, or very along the coast of Australia, most of these cyclones are located, most of these cyclones originate on the eastern part of the continents or on the western part of oceans. However, there are some cyclones which also occur on the western part of the continents. Examples like in the western coast of Central America and South America, cyclones do originate during El Nino years. Along the western coast of India and Arabian Sea, cyclones does originate. Like Nisarg has originated, causing havoc again. So let's now discuss first the distribution of cyclone and reasons why cyclones originate at a particular place. Right? Let's see. Now if you see the broad discussion, those who are using NCERTs, please you can refer to NCERTs, but in your atlas, be it the Orient Black Swan Atlas or Oxford Atlas, there is a map on natural hazards towards the end. In some editions it's on page number 114, some editions it is on 121, some pages it is 119, and if you see Orient Black Swan, it is on page number 89 or some 94. You can see the content and find out. So that map will give you an idea about the location of tropical cyclones. And if you see the tropical cyclones, these are located along eastern part of USA, right, in this Florida coast or the region near Gulf of Mexico, this region, where these cyclones are called as hurricanes. Then eastern part of Indian Ocean, eastern part of Australia, in the Indian Ocean region, cyclones do originate. This is another region of cyclones. Eastern coast of Africa, Madagascar, parts of Tanzania, and northern part of South Africa, Bay of Bengal, sometimes in Arabian Sea as well. And then if you look at the Pacific coast, these are located near eastern side of China, like South China Sea, where it is called as typhoon. It is also called as tofu in Japan, and Pacific coast, rather the southwestern Pacific or eastern part of Australia, where it is called as Willy. So now these hurricanes, Willy, typhoons, cyclones are basically the same tropical disturbances. They originate mostly in the eastern part of continents. But as I said, there are occasions where cyclones can also originate on the western part of continents. So here in the Central American region, in the western part of South America, cyclones do originate, but during the El Nino years. So this is one aspect of the distribution cyclones. So if you see the total number of cyclones, out of the total cyclones, 90% of cyclones are located in the northern Australia, northern Atlantic Ocean, and this northwestern Pacific region. And also they originate in this Bay of Bengal region. So if you see regions, they're almost fixed. Every year cyclones will occur in the particular region in different seasons. So we also have seasonality in these cyclones, like in before monsoon cyclones originate in Bay of Bengal. From June to November, hurricanes keep originating in the region. So question is, why do they occur at a particular place where they are? Why are they located in these regions only, and they're confined in these regions? Now, to answer this, we should be clear with two aspects. One, the local condition of the region, and second, general aspect of distribution of ocean currents. So I also suggest that please take out the NCERT and or the world climate map given in your atlas and see the distribution of ocean currents. What actually happens in the region is that ocean currents carry warm water towards polar areas and therefore increase the temperature along eastern coast of the continents. Like for example, for the demonstration's sake, I'm just taking example of Atlantic Ocean as of now. You can apply the same concepts in other regions as well. Suppose this is Atlantic Ocean, the equatorial part of Atlantic Ocean. At equator, ocean currents move from east to west. Now this is because of trade winds, northeast trade winds and southeast trade winds. Also because the rotation of earth is from west to east, so therefore some ocean currents, rather some water movement takes place from east to west due to inertia of water, exactly in reverse of movement of rotation of earth. So because of these prevailing winds and the rotation, ocean currents at equator move from east to west. From the western part, they move towards polar areas. Ocean currents move towards polar areas. Now that is because the temperature at equator is very high, temperature at poles is very low. So in the subpolar areas or close to polar regions, the density of water is very high because of low temperature. So therefore it subsides, it sinks there. And at the equator, water level is higher. So now what happens is, on the western side, is that water moves from this warmer water to cooler water. Because the warm water expands, right? So it moves towards a relatively cool region, relatively cool water in the polar areas. So the reason why water moves from equator to poles is purely temperature difference between the two latitudes. Now, what happens here? If it's a warm current, all of you can see your NCERT's ocean currents map given in oceanography, in ocean circulation chapter, and you see this current named as Gulf Stream. And it draws warm water towards north, towards eastern part of continent. So therefore temperature must increase. So increase in temperature can lead to increase in the rate of evaporation and therefore develop increase in rate of evaporation and low pressure. Low pressure means chances of cyclone. So frequency of cyclone is higher in this region, in this eastern part of continent, because warm ocean current draws a lot of water. Warm water increases the process. Same thing. If you look at the Pacific Ocean, so you should look at the maps carefully here for ocean currents. This is the western part of Pacific Ocean, and western coast of America is the eastern part of Pacific Ocean. So currents should move from east to west. So circulating this board, so you can see here warm water moving towards polar areas. Now again, there's a warm water from equator. This current is named as Kuroshio current. Right? It's named as Kuroshio current. Again warm water, higher temperature, low pressure, and rest process we understand. Same thing happens in other regions also. So please look at the map of ocean currents. I'll be referring this warm ocean current and the effect of ocean currents on global climate in the other topics, other discussions. So here, everywhere you see warm ocean currents. If I see this, if you can look at the map, the region, eastern part of Africa, there is this Agulhas current. Mozambique and then Agulhas current. Similarly, here we have East Australian current. So all of these water, all of these currents, they move from equator to poles, and therefore you can see by the map and compare these two, the rate of evaporation increases. Now, where is it happening more prominently? If you see the regions where the warm ocean currents show the prominent effect, let's start with here. In Atlantic Ocean, Gulf of Mexico. And name of the current? Gulf Stream. Call it as hurricanes. Then South China Sea in Pacific. South China Sea. Then Sea of Japan. Again in Pacific. Also the western part of Pacific along the Philippines coast. Other Pacific regions, other western Pacific regions. Here called as typhoons. In China, Tofu. In Japan, and Baigu, B-A-I-G-U-O, Baigu in Philippines. So these are regions. Another region is Eastern Australia, or it is the Southwestern Pacific, where it is named as Willy Willy. So I hope you can relate warm ocean currents along with these cyclones. Why cyclones or hurricanes are prominent in the region. Now, one region which we have not discussed so far is that why cyclones are prominent in Bay of Bengal. See, Arabian Sea is tropical, so is Bay of Bengal. But we see the frequency of cyclone is much higher in Bay of Bengal than in Arabian Sea. Although Nisarg has originated this year, last year we had Vayu in the same region. It is not that the cyclones do not originate in Arabian Sea. It is just that the frequency is lesser than Bay of Bengal. Let's compare these two. Why cyclones are more frequent in Bay of Bengal and less frequent in Arabian Sea region. For that, draw India map, a bit of, just for the demonstration's sake. Suppose this is the peninsular region of India, peninsular part of India, right? Arabian Sea, right? This is Bay of Bengal region, Now, Arabian Sea receives almost 9.8% of river water from Indian Peninsula. Right? That is around 23% of Indian rivers move towards Arabian Sea. If we go by volume, 9.8% of volume of Indian rivers drain in Arabian Sea. Here, around 90% of river water drains in Bay of Bengal. So, river water means fresh water. So, fresh water is less. Therefore, the salinity of Arabian Sea is much higher. Whereas in Bay of Bengal, because it receives 90% of the fresh water, the salinity is very, very low. the salinity is low. So I repeat this, just 9.8% of river freshwater from India, from Indian Peninsula, 90% of freshwater drains in Bay of Bengal. So this leads to the decrease in salinity in Bay of Bengal, whereas Arabian Sea salinity remains higher. Now why are we referring this point? Relate salinity and rate of evaporation. Higher the salinity, lesser is the rate of evaporation. Lesser is the rate of evaporation. Lesser the salinity, higher is the rate of evaporation. Higher rate of evaporation. Now, this is a very intricate concept. I'll just briefly elaborate this point. See, if you add salt to water, the boiling temperature increases more than 100 degrees Celsius. That's because when you add salt to the water, the vapor pressure reduces. So more salt means lesser vapor pressure, and therefore that means rate of evaporation is lesser. So saline water has saline water has lesser rate of evaporation, whereas less saline water or fresh water has higher rate of evaporation. Now one thing should be clear. If the rate of evaporation is higher, so we have higher chances, higher frequency of cyclones in Bay of Bengal, and therefore lesser frequency of cyclones in Arabian Sea. This is one of the reasons why we see more frequent cyclones in Bay of Bengal and less frequent in Arabian Sea. Let's go one step further, which has been recently found. See, yes, Nisarg is coming towards India. It has already made a landfall. It is already causing destruction and all that. So it might continue for a few days, cause destruction in Maharashtra and Madhya Pradesh. I hope everything remains fine. It causes less and less destruction. We are prepared for that. So, but if you see the general tendency of the cyclones of Arabian Sea, the general tendency of cyclones is to move westward. Last year, for example, Vayu originated in this Arabian Sea and it was about to make a landfall in Gujarat, but again then it diverted towards west. Now, according to the experts, they say that the high pressure, generally the high pressure prevails somewhere in this Arabian Sea region, rather the western side of India, southwestern side of India, which is the reason for westward winds. So cyclones which originate in Arabian Sea has east to west movement. So because of this high pressure that develops somewhere in northern part of Arabian Sea, coast of Gujarat or close to, so that pushes these those winds, because of the high pressure region, high pressure formation, push these cyclones towards west. So these are reasons why we have lesser frequency of cyclones in Arabian Sea and so on. Now, there is the second aspect. Let's come to the recent scenario. Amphan and Nisarg. Few days back, in the month of May, we had this Amphan super cyclone, and now Nisarg. Amphan is basically Thai name suggested by Thailand, meaning sky, and it was categorized as a super cyclone after super cyclone 1999 in Odisha. Nisarg is a Bangladesh name. Bangla name given by Bangladesh, suggested by Bangladesh rather, meaning nature, Prakriti. It's not typically super cyclone, but yes, it's one of the rare cyclone because the coast of Maharashtra has not experienced cyclone for a century. Last time it was in 1891 that cyclone struck Maharashtra. 1891. It's almost after 120 years that the cyclone is striking to Maharashtra. Here in this case, super cyclone, it's a frequent phenomenon. See, Amphan is not new, but its strength is a matter of worry for us. Nisarg, rare, because we generally do not have cyclones originating in Arabian Sea. Now, if you see these two, Nisarg is moving. The movement of Nisarg is south-west. Rather, it's coming from southwest. And all of you should understand, it's mainly because of southwest monsoon winds. We'll discuss southwest monsoon and monsoon phenomena related to monsoon later. But so southwest monsoon is pushing these winds towards India, towards Maharashtra. Because it's a monsoon time, it has already arrived in Kerala. So the general movement of wind is southwest, right, towards Indian Peninsula. So that is the reason why movement is towards Maharashtra and Madhya Pradesh. So same thing, Amphan moved towards, it made a landfall in West Bengal, the southern coast of West Bengal. Now, what is the similarity between these two? See, within less than a month, we had another cyclone. Now, as per the experts, the reason why cyclones have become so frequent, or they have originated so frequently here, is because of lesser concentration of aerosols. And why aerosol concentration is less? Is because of COVID-19.